Right.
All right, ladies and gentlemen, I'd like to bring this meeting of the Delaware Astronomical Society to order for June 2022. First thing, do we have any new members like to introduce themselves? Let me turn this around for you. And tell us a little about yourself.
Good. Keep it less than a half an hour. I don't think that'll be a problem. My name is Jason Lennon. I'm a resident of Wilmington. And just a fan of the stars. I'm not an astronomer and I'm a chemist by training. So I'm just a nerd at heart, and I've been interested in the stars for a while, and I hope to be able to come up here and see what everybody's doing.
Fantastic.
Well,
Awesome.
Kevin? Jason. Okay.
Jason. Wonderful. Welcome, Jason. Anybody else?
How'd you find us?
Okay.
All the Mount Cuba Observatory, and
Yeah.
And I think that she just said to show up next Tuesday, and right.
Cool.
Okay.
Very good. Anybody else? All right, we'll turn that back around. All right, so next thing, Sydney, can you give us an announcement about the election?
Okay, yeah, if you could turn it around.
We don't hear you.
He's not.
He's not muted.
I'm not muted. Let me see.
Something wrong with this app again?
You might be coming out on the projector again?
Oh,
Okay,
you know
let's
what might
see.
have happened, Rob?
I don't think it's working.
Let me see.
Music off, did you turn something out?
Well, we
Yeah,
We heard
you may
the
need
music,
to
so
turn
it's
it
on.
on Zoom.
There he
Okay, it's
is.
fixed now.
It was.
Okay, can you guys hear me better?
Yes. Here we
All
go.
right, good evening, everyone. I'm saying hi to you from the other side of the planet. As the elections chair, I'd just like to take this opportunity to mention to everyone the results of the election. And if you are here, you can either stand up, or if you're in Zoom, you can wave. Our secretary for 2022 to 2024, Bill McKibben. Hey, Bill, congratulations. Yep. And our treasurer, Bob Treblecock. Hey, congratulations, Bob. Our vice president, Jeff Lawrence. Hey, how are you, Jeff? Congratulations again. And of course, for president, Rob Lancaster. Congratulations and welcome. And their terms will begin on July 1st. And that's pretty much it. Thank you and congratulations.
All right,
Thank you.
Thank you very much, Sid. You did a great job. All right. Next item is the new equipment. So we just got a lot of new equipment. For those of you that attended the last meeting, are well aware of that. And it was two massive donations, very generous donations, one from Chris Abisi and one from Ted Trevorrow. And we got some nice new lunar telescopes. We got some nice new astrophotography gear. It's going to take us a while to go through it all. So probably the next few weeks, we're going to be just going through and testing things and figuring things out. But it's really very exciting and should make a really big difference for the membership. Next thing is Bob with the Astronomical League.
As a DOS member, you have the option to join the Astronomical League. It costs $7.50 a year, and their membership goes from July 1st to July 1st, so it's coming up. What the Astronomical League is a group that promotes amateur astronomy, astronomy education, and outreach, and they're most known for their observing awards. They have like 65 observing awards that covering all sorts of things: messier objects, planets, urban astronomy, globular clusters, you name it, they've got an award for it. And they have different levels: beginner, advanced, and some of them are visual awards, and some of them are astrophotography type of awards. So they have a little bit for everybody. So if you're interested in joining that, the last focus, you got a letter from me telling you how to get it a couple of weeks ago. You might have that in your email. And the last focus that just came out, the last 2 pages, tells you how to sign up and pay for that. And of course, if you're here, I'm here to collect money. So again, it's $7.50. It's optional if you want to join. You get this magazine, the Reflector magazine, 4 times a year. And so, if you're interested, we got till about July. Well, you can join sign anytime, but I'll be putting in this next year's roster on July 1st. So I was trying to get it collected for that.
Brilliant. Thank you very much. Bring that back around. All right. Bill, you want to give us an update on the AP Sig?
Sure. So the June meeting for the AP Sig is this coming Saturday at Rick Spencer's. It'll be 7-ish. Depends a little bit on the weather exactly when we'll start. The weather's been improving for the coming weekend, and if it gets good enough, we'll put out a general invitation for people to bring their scopes and do some imaging on the site. Otherwise, we'll be mostly talking about Rick's observatory and some improvements, including roof automation and, of course, astrophotography in general. And then in July, we'll meet at Bob Treblecock's on July 9th, Saturday, and we'll be looking at his roll-off structure observatory, as well as talking about absolute encoders for equatorial mounts. Okay, that's it.
Good, very good. Next item is the book club, and he said he'd say something.
The book club's going to meet via Zoom on June 30th at 7 p.m. The discussion is the book, the biography or autobiography of John Brashear. John Brashear was a major telescope maker in the 1800s. We're going to have a guest speaker, Bart Freed. Bart Freed is an expert on Brashear and the Brashear Company. And, it has significance here because the antique refractor we have mounted up in the dome has a Brashear mount on it. And the DuPont, FG DuPont, who owned that telescope, also had a 12-inch Brashear reflector at the site at Hagley. So I hope we can join us and, have a nice discussion about John Brashear's life.
Awesome. Thank you very much, Dave. And next item is Fred. Tell us about Friday Night Lights. Did you have a presentation on here? Yeah. Careful there. All right.
I'm okay. I'm glad you're okay.
I'm fine. Don't hurt yourself.
Why not to?
Well, you gotta have a doctor in the house. So.
Oh, yeah. That's
There is, yes. Where's my presentation?
Where's the presentation?
It's in that folder right there, behind.
So down here. You see it?
Right there, the
A little
yellow.
bit.
That?
Go roll more.
That-
There.
oh,
That's it.
Yeah, there you go.
uh-huh.
And that needs to be shared, Rob? or-
Yes, I can do that real quick if you want. So I have to click this button. And then you can maximize that. Great. As you like.
Oh, I see.
And Rob, do you want to put the, put it in speaker view, just so we don't have as many?
Let me see. There we go. When you start talking.
Hey, Bill. Okay, Friday Night Lights, this is the first Friday Night Lights that the Natural Lands is having in 3 years. The last one was in 2019. And it was a really big turnout then. And we've already had a number of, quite a few volunteers come forward. But for those of you who aren't aware of what Friday Night Lights is, it's a combination of music and telescope observing at the Natural Lands Chesnut Preserve in Coatesville, which is not too far from Longwood Gardens. We can still use, we're not turning away any telescope volunteers at all. I think we have 20 or 21 or 22 volunteers now, but we can use all we can get because they've sold 400 tickets and it's usually a sellout. So they're expecting 650 or more attendees there. So if it's a decent night, it'll be a very busy night for telescope observing. So what I want to do by the end of the month, I want to give the list of volunteers to the Natural Lands. Each telescope volunteer can bring 2 guests. Any more than 2 guests, the 3rd guest will have to register through the Natural Lands website.
And pay, right?
And pay, yeah. If you're a Natural Lands member, I think it's $35. If you're a non-member, it's $45. We need to get there before 6 p.m. when the gates open. So if we get there between 5 and 6, we'll avoid all the arrival of all the guests coming for the event. That night, there's going to be a 70% illuminated moon. And the rises about 3 p.m., sets about 1. And there's not going to be any planets out on all that night. So the moon is going to be the event that night. After the event ends at 10 o'clock, we can stay observing if we want, but what I'll do, I'll go around up and down the telescope line telling you to shut it down and thank the guests for looking through your scope. But you can stay observing if you want, just make it look like you're getting ready to leave so the guests go home. There's quite a few differences this year as opposed to previous years because of COVID-19 precautions. They wanted a minimum of 20 astronomers. We've already met that because we didn't want too many people crowding around the telescope that could be possibly cause issues for COVID. Anyone that's unvaccinated, they're asking them to wear a mask. The Natural Lands is also asking anyone who visits the telescope to wear a mask. They will be providing 2 volunteers to hand out masks, and they're also going to be giving out masks to the astronomers to hand out masks to the people looking through the telescope. 2 guests per astronomer are allowed to come. As already mentioned, the location of the telescope setup is going to be on top of the hill behind the stage, which is a really nice location for us as opposed to in previous years where they had us down near a parking lot, which was not really opportune for the telescopes. There'll be some trash cans and recycling cans there for people to dump their trash when they come up to the scope, which was an issue in the past. Unfortunately, this year, none of the vendors are giving out tickets for free beer or free food. Everybody's feeling the crunch of the inflation, I guess. So if we want to drink beer or have any food there, unless we're bringing it ourselves, you're going to have to buy it from the vendors there. And there will be.
You're allowed to bring your own food and drink?
I am.
Yeah.
There'll be water and non-alcoholic drinks at the Red Natural Lands tent down in the vendor area for us to partake in, and anyone else too. Again, upon your arrival, look for me so I can give you your name tag so you can be identified along with the club. The local craft beer will be from East Branch Brewing Company and the Animated Brewing Company. There'll be the Stargazers Vineyard there for the wine. And food truck fare from the Gourmet Jerk Shack, the Grateful Gourmet, and Every Soul Vegan Bakery. So everyone's going to get their share of whatever they want. They pay for it. Ticket sales are limited, so if you have guests beyond the one you're allowed to bring, get them to sign up on the website because tickets will be sold out. There will be an additional $10 charge for anyone who wants to buy a ticket at the gate. Gates open at 6, but again, we should be there between 5 and 6 to avoid the crowd.
Fred, I don't get that last comment.
Unless you're telescope volunteering, then arrival time should be between 5 and 6 p.m.
I'm confused by the grammar.
Me too. If you're telescope volunteer, you can get there between 5 and 6.
Yeah.
Thank you.
Okay.
That's what should have been said. I'll have to talk to my editor. Live music will be provided by the Flying Komorowski Brothers and Sweet Lizzie Project. I have no idea who these people are. They're outside my wheelhouse. But this guy looks like Daryl from The Walking Dead. Maybe he is Norman Reedus. I don't know. Some photos from previous Friday Night Lights. So you can see it's a fairly crowded event. People having a good time listening to the band. And then it gets blank. As twilight hits, crowd continues to show up. And there's usually a bonfire for some s'mores. I don't know if they're going to do that this year. This is one year at the Lunchfest Center. Bunch of DAS guys having a good time out there on the field. There's our treasurer, the great two-fisted drinker. And this is the telescope hill. We'll be lined up.
Hey,
And
Fred, could you check the chat real quick? You see it that's at the top? Chat with the.
yes. Sweet Lizzie Project was the headliner at Ladybug New Orleans Festival last year. Thank you very much.
Cool.
Thomas.
You just hit the X then.
Doesn't say if they were good or not. Next.
Oh, maybe try clicking somewhere on the screen.
Click something.
And this is an aerial shot of the event as it was still underway yet. That's not the complete crowd. This is the telescope. No, this is probably around
147.
This is probably more closer to, the event that year began at 8 o'clock. So this is probably closer to 7. And most of the people show up after 8 anyway.
Same location as this photo?
Same location.
This year will be at the same place as this.
Same
photo?
location as
And the
the
scopes will be where?
The scopes will be right where these guys are.
Yeah.
We are there. You can't really tell the hill there, but the hill here is
Oh, yeah.
is a detriment sometimes to those who drank a little bit too much beer and wine. You'll see them get halfway up the hill, then they start coming back down again because it just, the telescopes may not be worth it.
It's a good filter.
Yes.
Yeah, that's a good book.
Yeah.
That might be good.
If you can't make it up the hill, we don't want you to do the scopes.
So we've got 21 participants, bunch of people from DAS, from Chesmont, from the Chester County Club, from Bucksmont. I'm the astronomer coordinator. Again, if you don't have a guest yet, let me know if you're bringing a guest, and we can get them in for you. Looking at hand up there. Friday Night Lights, save the date, July 8th, 7 to 10 p.m. 5 to 6 if we're showing up the telescope. Otherwise, you can bring 2 guests with you for free admission. Filming, redworld@verizon.net if you want to participate.
Cool.
And if you want the Natural Lands website, it's naturallands.org. Thank you very much.
Thanks, Fred.
Nice job, Fred.
Thank you.
Make the 1 minute mark.
You're good.
Okay.
I'm gonna stop the share for now.
All right, let's just see. As I speak. Oh, there he is. Okay. All right, John, are you with us now? Yeah.
I'm unmuting and starting video. There we go. How are you
Hey,
doing?
John, welcome. All right, our main speaker for tonight is the return of John Conrad, who is our NASA ambassador. He frequently comes and gives us updates about what NASA is up to, which is really cool because they're always up to so many cool different projects, and half the time we're not even sure what our hard-earned tax-paying money is going towards. So John Conrad, our NASA ambassador, is joining us again tonight. Tonight he is going to be talking about an interesting NASA mission. The title of his talk is "Do Look Up," and it's a NASA mission where they are going to be attempting some technologies to deflect asteroids, which could be very critical at some point in the future. Again, because we're doing this hybrid Zoom and in person, in a second, I will swing the camera around to the audience that is here in person. John, this is being recorded. We typically put the recorded videos up on our YouTube channel. Do you have any issue with us doing that?
That's great.
Cool. And again, once we've done that, I will shoot you a link to that YouTube video for your purposes. Once we kick off John's program, we will mute everybody except for John to make sure his audio comes through to everybody very clearly. John, how would you like to handle questions? Would you want people to break in and interrupt or save them till the end?
Break in and interrupt. That's just fine.
Okay, so for us here in person, we'll jump in and interrupt John if we have a question, or if anybody on Zoom has a question, just feel free to temporarily unmute yourself and ask your question. Just the favor is, if you do ask a question, please, after you're done, remute yourself because nobody's going to be manning the computer at this point.
The space bar is good for that.
Yes,
because
yep.
It'll unmute and then remute.
So first step is, let me
Just turn that.
swing this around.
Good.
Yeah, sure, that'll work.
Yep.
And Rob, do you want to take it from here? You're better with getting all the settings right. I tend to. Okay, and John, we'll just make sure, yeah, John, you can unmute yourself, John, and go ahead and start.
Okay, can everybody hear me?
Yes.
And it's great to see all of you in the room there. I assume that you're all cheering because I'm back, but I can't hear you because you're muted. Anyway, it is great to be back, and I appreciate the opportunity to do these things. As you just said, Jeff, NASA does keep at a faster pace than they did 20, 25 years ago, doing important things, I think. So it's good to have the opportunity to talk to you folks about it. And I guess let's get on with it. Let me see if I can do my screen sharing here properly. And can everybody see that?
Good to go.
Yep.
Okay, I want to get this bar out of the way here at the side. Not that I'm not at the, the same category here as, Jennifer Lawrence or one of these folks. All right, here we go. So I'm guessing that a lot of folks in the audience here saw this movie. And while it was kind of a comedy, we all are aware, people like us, I should say, are aware of the seriousness of a comet, a rogue comet coming to Earth. And I'm afraid that at least I'm aware, and probably many of you too, that the idea that a political party would actually decide to take something this serious, that's one problem, that they would actually try to divert people's attention. The bigger problem, of course, is the fact that so many people would actually pay attention to that kind of nonsense and not look up. And so this was all about a NEO impact. And tonight I'm going to talk to you about, if I can get my clicker going here. Always time for one. There we go. That the time is coming when you guys should look up. And the cartoon there, or I should say artist concept on the right, is a real picture of a spacecraft named DART that we're going to talk about. And it's not a real picture, but a representation of a target asteroid that we're also going to talk about. So let's get on with it. And the name of the, I want to get this out of the way here, sorry. Keep getting stuff stuck on the side. The name of the DART spacecraft stands for Double Asteroid Redirection Test. So as you folks understand, there are lots of binary asteroid systems. This is one of them that was found some 20 or so years ago, and it was selected some years back as the best target. And so, of course, they had to schedule things so that we could launch into a near Earth or into an orbit that would go around and converge on the asteroid, getting there at the time of closest approach to the Earth, which you'll see in the animation pretty soon. Tarek Daly did a fantastic job with these slides. I want to give credit to him for most of the slides. And I also want to note that the manager of this spacecraft, the developer and manager and operator, is APL, which I assume a lot of you folks know. JPL's famous. APL is probably next, as well as Southwest Research Lab, who did New Horizons and some other things. There are several of these contractors that regularly serve all of us by building deep space spacecraft of various kinds and near Earth spacecraft for NASA. APL has been at it a long time. If you aren't familiar with them, my first crossing paths with them was launching one of their very small satellites in 1968. What's that, 54 years ago, from a launch site that's about a quarter of a mile away from the one that launched DART recently in California. And I guess since I started a personal note, I'll finish and note that the satellite that they provided in '68, along with about a dozen other small satellites, went on a very long stack on top of a unique booster configuration, an Atlas with something called a burner 2 on top of it. And the whole thing had a very long fairing being used for the first time, which did not separate. And instead of all going into orbit, they went into the South Pacific about 15 minutes after launch. So that was not uncommon in the first decade of launching stuff. But anyway, that's my background with APL. I hope they don't remember me. So there's quite a team that's been involved in DART. many of the NASA centers in the upper left there. And you see JPL, and JPL is not a NASA center. You probably know that. They're a contractor under Caltech, just as APL is a contractor. And then there's a whole assortment of commercial companies, universities, and national labs, also with a hand in DART. The overall mission that to me is kind of exciting that it showed up in the last couple decades, because frankly it needed to, is that of planetary defense. And the folks that keep track of the near Earth objects that threaten Earth, that we need to track because they're in near Earth space and could potentially collide with Earth in one of their heliocentric orbits, is the Minor Planet Center. There you see it at the top, the International Astronomical Union's Minor Planet Center. We showed in a previous talk about NEOs the literal cloud of NEOs that we have now identified. We've searched for them with a variety of telescopes, mostly Earth-based telescopes. Many of them were survey telescopes that could keep at it, covering the whole sky for years. And so we've actually built up an inventory of known near-Earth objects and their orbits and numbers for them that we revisit regularly to update their orbital elements. And it's, I believe, well over 500,000 now. And so that's what IAU MPC does. The upper right corner is where we start the strategy of the planetary defense people with all those telescopes. And further, as we go around the wheel here, clockwise, the next thing they want to do, since they don't get much detailed information about these very dark near-Earth asteroids for the most part, is to characterize them further in terms not just of size, but shape, if possible, and composition. And so they go to the infrared, they go to radio frequencies and so on in order to get more information about them. Down at the bottom is an indication, you see NITEP IWG. The I is the International Working Group. So while the US has set up a planetary defense effort, and we're probably the lead agency and nation, with the guy reporting at the top of NASA, there are many other developed countries now that have planetary defense efforts, as you'll see in a minute. ESA, European Space Agency, certainly does. And so they've been having tabletop exercises and communications exercises to make sure, since this, like climate change, is a global problem, that they all have ways to find things, study them, and keep in touch, and then coordinate efforts. And one of the first things, frankly, we should all be thankful for, I guess, that they've done, is to go backwards and forwards to scratch their heads and try to come up with a variety of mitigation techniques if we ever identify the asteroid with our name on it. No matter how many years or decades out the calculations say it's going to intersect. And so they've done some exercises of that. The mitigation approach over there in the lower left is the one that we're addressing tonight, because the very first of the tests of a mitigation approach is the DART spacecraft. And you see there that the Planetary Defense Officer was established in 2016 and is leading a lot of this stuff and coordinating it internationally. All right, so the threat. You probably remember from my earlier NEO talk, as I just mentioned, that literal cloud of NEOs that's out there that we're trying to add to all the time and keep track of. This particular graphic shows about 30 plus years worth of NASA sensed near-Earth asteroids that actually entered the atmosphere and either ended as a fireball or on the surface. And there's probably over 300 of them there, which might seem impressive, although there are many, many more than that that have come into the atmosphere. And in this case, I want to note that this is the ones only above 0.1 kiloton. Now, that sounds, because it's a fraction 0.1, like maybe it's not that big, but a ton is 2,000 pounds, a kiloton's 2 million pounds. And so 0.1 of that is 200,000 pounds of high explosive, which is not a small explosion. So these are all very large. And of course, the largest there jumping out at the top of central Russia there is the Chelyabinsk impact that actually didn't impact, fortunately. It was about, I think, 20, 30 kilometers up. And it ended in a massive fireball and had the equivalent of half a megaton of explosion. So thank goodness it wasn't right over an urban center. It was near enough to some cities that there were over 1,500 casualties from the concussion, especially from broken glass. So there's a good indication of how many of these things show up on a fairly regular basis. And so now let's look at it from another standpoint, because we've been counting like crazy for about the last 30 years. On the right there are the real worrisome ones. You're well aware that 10-kilometer asteroid is large, will cause enormous damage if it actually gets into our atmosphere and down to the surface. As it says underneath it in the legend there of the impact, global devastation. The reason we know this is from the cartoon and the fact that this is actually the size, 10-kilometer diameter of the Chicxulub asteroid, as near as we can estimate. And the frequency with which these things are likely to arrive, the larger you get, the smaller the population of things we actually know about from craters. And so those are guesstimates on the right. Hopefully it's going to be at least 100 million years and not 66 million or something like that. But at any rate, it's a long time between these, we believe. And we've been madly searching, and we estimate in near-Earth space that there are 4 of these. I shouldn't say that. We have found 4 of them. We estimate that 4 is all that there are. And the reason we feel highly confident in that is because of the size. They're not hard to find. Going down a level, though, we get to a kilometer-sized asteroid. And those also, as it indicates, can cause global devastation and possibly the collapse of civilization, not as many species and as rapidly as the 10 kilometer size, but because of the devastation to populations around the world and the nuclear winter effects and so on. Those, and as you go down the chain, you all understand, will be greater in number. And so we estimate the population to be about 900. We've found about 90%. So there's about, we estimate we have about 100 more of those to find. Our estimates increasingly as we move down can be more, in terms of frequency, can be more accurate because we have an impact database filled with hundreds of craters that we found around the world. Obviously, those are just the ones that hit land, which is less than a third of the area of the globe. And so we're able to estimate from those something about the frequency. As we move down further, we find that at the 160 meter size, which I'm going to say, not to steal the headline, is probably the ones that we're most worried about because they are so numerous. And because we believe we've only found about maybe 42% of them, meaning we've found 8,000, but we have another over 10,000 that we haven't found yet. And these have an explosive yield that if it happened to be in a metro area or even in a well-populated county, could cause mass casualties. So we're looking hard. I'd have to say that's really an area that we're looking very hard at to try to bring the count up and also figure out mitigation techniques. And then you get down to the smaller objects, which are much more numerous. And of course, less impact. We don't worry about 4 meters. Pretty much bright flash, no ground effects. And the 25 meter also can be damaging, as I'll show you with a couple examples here. One was at 40 meters, and that's a very, very crude estimate, from an impact in eastern Siberia where almost no one lived, where the teams that went and studied the blowdown of trees got there a couple decades later. So we're really, really guesstimating 40 meters. At any rate, it did have a real impact on lots and lots of forest. And fortunately, there weren't many people, if any, in that part, and no known casualties. In the same class size is the Chelyabinsk, which I talked about a minute ago. And at only 20 meters estimated diameter, it had that half megaton impact in the air. Fortunately, not near people, but it caused plenty of casualties. So that's an area where we can look at the frequency, early 20th century, early 21st century, and it fits with what we're saying there, about 1 every 100 years. And I want to dwell a little bit on one that we also have looked at, which is the Behringer meteor that has a crater in eastern Arizona, which we estimate it was prehistoric in terms of our written histories, 50,000 years ago. And so this is a good one to look at in terms of seeing what the impact would be over a distance. And so, as I said, 50,000 years ago, we think it was a metallic asteroid that hit at a steep angle, which is probably one of the worst ways for the impact. The crater, which is easy to visit off the interstate, only a few minutes drive. You can walk up to the edge of the crater and be impressed by how wide and deep it is, and buy something at the gift shop maybe. And it's kind of a nice visit, but at any rate, the point is the fireball reached out about 6 miles, 10 kilometers, everything gonna be dead there. The killing area or casualty area, at least for animals, would be out to about 15 miles, and the hurricane force winds out to about 25 miles or 40 kilometers. So lots of devastation from something at the 50 meter size. How does that look if you put it in a populated area today? Well, if you make ground zero there where the Behringer crater is, the center of DC, the fireball area would effectively incinerate everybody in the district. And rather than pause and think about whether that's good or bad, I'll just go on and say, beyond that, out to that further reach of many, many casualties takes you well into Virginia and Maryland. Lots of casualties out that far. Oh, and out to the Chesapeake Bay for hurricane force winds. So these things cause a lot of devastation. In about 3 years ago, they had their International Planetary Defense Conference in Maryland, and they chose to have a tabletop exercise about something that would hit right in the middle of Manhattan Island with an unsurvivable zone, the fireball there covering a lot of the Manhattan Island and into Long Island and New Jersey and so on. So we've looked a lot at the devastating impact of asteroids that aren't even up to that 160 meter size. So here is another way to look at the size of the asteroid and look at the studied and currently under research and design techniques to mitigate any of these if we identify them out there and can, by our orbital mechanics calculations, watch their trajectories for years and identify how many years out the collision with Earth in its path would be. And these things we estimate out with all the ones we've found so far. And so far, we haven't found anything of a meaningful size that is going to impact us, according to our calculations, out at least 50 years. But we do worry about things 20, 30, 40 years out if they're the size of, say, a dinosaur killer at the top of this, this graphic here. And so the only thing that we estimate could be done to get rid of one of these, there's no way to deliver enough energy to it without having a nuclear device delivering the energy that we know of today. And so even if we have a long lead time, we still have to go out there and use a nuclear device, which in itself is something we are really worried about doing, because you're probably aware that we think asteroids are made up of many smaller pieces in many cases, and we could end up with a nuclear blast that takes a 10-kilometer diameter object down to 10 1-kilometer diameter ones, many of which would impact Earth in different places. So it's not a technique we ever want to use. And so let's come down to the ones that we're really worried about here in the 160 or so kilometer range or meter range. And there you see the kinetic and the tractor techniques. And you may remember, tractor is nothing more than let's get as massive a spacecraft as we can out there to it as early as possible, park next to it, and let the mutual gravitational attraction that they will have tugging on each other pull the potentially dangerous asteroid enough off its track that you will have a delta V change that will have it miss the Earth some 10, 20, 30 years out. So if it's small enough, if we have enough decades lead time, that's one that we probably can plan on using. It's very passive. But otherwise, the technique we've come up with is deliver energy in some kinetic fashion. And so that was identified by the National Academy of Sciences team in 2010. They said the first priority should be an experimental test of a kinetic impactor, and that's what DART is all about. All right, so now let's look at the target for the DART spacecraft. As I said, a binary double asteroid system. The parent, the larger one, is Didymos. And to get a feel for the size, there's a couple famous skyscrapers. So it's quite a bit shorter than the Burj Khalifa on its longest dimension, and it's bigger than the World Trade Center. But of course, its mass is really what counts, and it's much more massive than either of them. Dimorphos, which is actually the target, is 163 meters, so it fits right into that category of 160 meter that we've been counting, that we think there are still thousands of up there that we haven't found yet. And that particular one is somewhere in dimension between the Statue of Liberty and the Eiffel Tower. It's about as massive as the Great Pyramid of Giza. And this is an image that I really like. There it is, hovering over the Colosseum, if you've ever been there, waiting for us to hit it. So what are we going to hit it with? Well, there it is, the DART spacecraft at 19 meters. Not very large, bigger than the length of a bus, shorter than the Arc de Triomphe. And what counts is the mass and the velocity, i.e. the momentum. And so we'll see how that works in a minute. So we have seen this double asteroid system, as I said, for a couple decades, going back a couple decades. Here it is from one of the many Earth-based telescopes that have seen it, the BLT in Chile. It is the very small object fixed in the center with the star background moving. You folks understand that. And nothing resolved in the way of two asteroids. And that image that you see at the size is a guess. It's a guess that's educated. It's based on information about the light curve from the fact that we have the smaller passing in front of and behind the larger asteroid. And it's also from some radar data that was acquired. some years back. So we think it's kind of that shape. What we know about Dimorphos is nothing. We know it's there in the same sense that we know the exoplanets are there from the light curves diminishing when the planets pass in front of distant stars. That's the way we know that Dimorphos is there. We think it's likely to be sort of like one of these shapes that we do know about and have seen up close. And so we've said it's this. And you'll see this picture, probably it'll show up in the paper about the time that impact's about to take place when they get the press releases out there. But you have to understand that this is just a guess at what it might be, sort of bilobed, and we won't know until literally the spacecraft gets up close what it is. So without dwelling on, without just jabbering on, I'm going to show you an animation here of where we are in the mission so far, having launched on top of one of the Falcon boosters from the Vandenberg Space Force base. And I don't know if you folks have caught on to the fact that the new Space Force has quickly renamed a bunch of the appropriate bases, like Vandenberg Air Force Base, where I used to work. And so the Vandenberg Space Force base launched this at the end of November, 7 months ago. And so here's an animation of this whole thing. Point out a few things as we go. Falcon rocket. Here goes the rolled up solar panels on the vehicle as they roll out. We'll look at this in a little more detail in a minute. They're each about 30 feet long. Cover comes off, the most important feature to hone in, and that's the camera. And now we see that we've timed it so that after launch, it arrives at the spacecraft next September. And here is the Lychee Cube CubeSat we'll talk about also, because it gets deployed 10 days early, and after the impact from the main spacecraft, the CubeSat flies by 3 minutes later and takes some pictures of something like this. Well, I'm going to show you that one in a minute, but the impact. So here's what we know today about our target. There's Didymos in the middle, 700 and some meters, and there's Dimorphos orbiting it with an orbit that's been very carefully calculated now by a number of Earth-based telescope. Here comes DART. There goes the CubeSat to watch. There's the impact and the CubeSat flyby. So that's what's going to be happening. And the key thing is to deliver enough momentum to change it and put it into a new orbit that we can calculate by the same technique that we've been calculating the existing orbit from Earth. And so let's take a look at that. We'll get to that, I guess, in just a second. Here's the statement of the 4 requirements to be met by the mission. As I just said, the impact is coming up. It says September, October. They're currently estimating, because it's actually been flying now for 7 months, that September 26th is the day of impact. The point of it, of course, is to change the orbital period of this binary system. And the change of greater than 73 seconds is what they're estimating. And that will be sufficient to prove that we actually could have some ability to change the velocity, which is the key of any dangerous Earth threatening asteroid. The way we've been measuring the period and the way we will measure it to see if it's changed is with a number of Earth-based telescopes. And in addition to just knowing that we've changed the period of the orbit, we want to understand more about the composition of the asteroid and what its reaction is to a kinetic impact like this. And so we're going to measure something called beta, which we'll talk about here in a minute, but basically it's enhancement to the momentum. So here is that light curve technique, which I think you folks are well familiar with, where each time the smaller body passes behind or in front of the larger body, as viewed from Earth, you see off to the side here, you see a decrease in the combined light curve. And over a period of observations, you get a very accurate estimate of the period, which is on the order of 11.9 hours, I think. So here's a list of the variety of Earth-based telescopes that have been so far employed to get a look optically at the double asteroid system. And I'm sure that a lot of them will be vying to come up with the first measurements, looking for any change afterwards. Here is what we expect to happen upon impact and what it means in terms of momentum transfer. If you have only MV, mass times velocity, impacting a much larger mass with a much smaller velocity, you have some change, some momentum increase, if you will. And in the case that's modeled there on the left, there are no ejecta. In other words, if it was a perfectly inelastic collision like a cue ball hitting the 8-ball, that kind of thing. Nothing spalls off, nothing is ejected. In the middle case, you have a collision that causes a cratering and some of the ejecta to be pushed off. And by Newton's third law of action and reaction, just like rocket thrust, that means that you will actually deliver a small amount of thrust to the object that you're hitting and increase that velocity change, the momentum increase. And if you get a lot of ejecta, you get even more of a momentum increase. So we want to understand the composition, we want to see the crater, and we want to be able to observe and calculate this to the maximum extent possible. Here's another way that NASA has, it's probably APL has actually built the models. A no porosity case on the left there with a certain beta value because there's very little in the way of ejecta. In the middle case, something like styrofoam, they said, they claim that the beta value goes down and the velocity change is up. And I don't get it. And so I've put in a question to the folks at APL, and they've scratched their heads and they're promising to get back to me. I've been waiting a couple of weeks now. So we'll see. I'm eager to learn about these things. I mean, I remember from statics and dynamics studying this kind of thing. Anyway, on the right really is the case that they modeled that most fits what we think small asteroids like this are like. And you're aware of the term rubble pile, I imagine, which means essentially that in these areas of lots of space dust and small planetesimals that find each other and gravitationally attract and eventually agglomerate a much larger body, they've modeled it with all sorts of small to medium to bigger to huge pieces, and they've modeled what the impact would do and show it giving quite an ejection, or I should say quite a thrust from the ejecta, quite a velocity change. So we will see. Here is the spacecraft, 2.6 meters at its longest dimension there. It's on the order of 8 feet or more. You see on the side there, on the left, Lychee cube. It's an Italian built and provided by the Italian Space Agency CubeSat, which I'll show you in a minute. And it will deploy from a spring-loaded box on the side there 10 days before impact next September. And so there is the key telescope camera, Draco, on the left. And I'll show you more about that in just a minute. If you flip it 180 degrees, you see on the other end for steering, we have a bunch of hydrazine thrusters, and we have the critical antenna for command uploads, and especially in the last days, it'll be on constantly broadcasting down information from Draco to the ground so that we can see what's coming and actually see the collision in real time. And at the right there, you see the 60 plus feet long telescope with most of the mass concentrated there in the center. And so let's look at that center spacecraft as it really looks, all ready to be shipped to the launch site with the solar panels rolled up. And to give you a feeling for that, I thought maybe you'd be interested to see that it's about the height of Shaq, reaching over the top and putting his hand, you know, probably firmly on the top of it. That's about how tall it is, and much, much bigger than Shaq. So it's not small. 633 kilograms, that's about 1,500 pounds. That's about the size of a smart car, or I should say the mass of a smart car. So you get a feel for it. So here's that Italian-built Lychee cube spacecraft, which you might know about in terms of the standard form factors now that are being used all the time for CubeSats. This is a 6U. What that means is you have a box about the size of your Kleenex box, and you put two of them next to that, and then you stack those three on top of another stack of three, and that's really what you've got there to give you a physical feeling for the size. And as I said, it's got two cameras on board, and here they are, and they were named Luke and Leah by the Italians. So credit to, I guess, George Lucas there. At any rate, the resolution, as you see, is not very great, 2 meters per pixel. So we're going to learn something from this. We're going to learn, hopefully, quite a bit from the Draco camera telescope that's on the main spacecraft as we approach. And so let's take a look then at the operations when we get there in September. Here's what Draco means. Camera for OpNav, and you're going to see a simulation of OpNav in a minute with the cover off. And I know you folks like more details than that. So what we have here is, what's that, about an 8-inch aperture. And you see the field of view. So that's what we've got there. And like I say, they're hoping to get some good resolution pictures as they approach the currently unknown size and shape of Dimorphos. So here is the timeline for what's coming up, beginning at 30 days, which is toward the end of August, when for the first time we expect Draco to be able to see the system. And of course, initially, it's only going to be seeing, you know, something that it can't resolve as 2 objects. At 10 days, a few weeks after that, the ground antenna coverage will be continuous through the impact. In the last day, at 4 hours, they finally will enter the terminal phase, and they will enable the smart navigation, and it'll be on its own, guiding itself in at that point. And in the last hour, it will be 24,000 kilometers. That's about 15,000 miles away at this point. And the reason they gave us the details is, as you can see, for the first time, theoretically at least, the smaller body, the moonlet that we're aiming for, Dimorphos, will be visible in at least 1 pixel. And so it's the first observability, possibly, of the second of the 2 asteroids. Now, at 15,000 miles away, 60 minutes away, So as you see, it's traveling at 15,000 miles an hour. So it's going to hit it pretty fast. Here is a simulation of what takes place in that last hour. When I put it into motion here, you'll see that in the lower right-hand box there, the outer box, the white box, is the field of view, and the yellow box is the box that is blown up on the left there and is the data that will be downlinked constantly. And so here you can see speeded up the last hour, 30 times real time, so every minute is 2 seconds. And you see the thrusters firing to steer it towards this object that it's trying to keep centered. And I'm going to go forward a little bit here rather than spending minutes at this. And we'll jump way over here. And now we're down to the last 15 minutes. We have now, as you can see, established an aim point on the smaller body, which we're approaching rapidly here. We're still in a few minutes out, and so it's still a fast animation. At 2 minutes, we'll go down to a slower time as we come to the end. And you see a lot of thrusting by the hydrazine thrusters. And finally, we're down to the last 2 minutes. We've slowed things down. Every minute's 12 seconds. So we're coming in close. We're finally going to discover the shape. And hopefully, if all goes well, we'll be watching in real time as the impact comes. And the end will be possibly quite interesting. Here it's pretty boring. So what we think it'll be like if you could be up close is something more like this. And remember, there's a CubeSat that's going to fly by here in about 3 minutes and hopefully get a good look at the crater and the ejecta. So now I'm going to maybe surprise you. It kind of surprised me that there's a sister mission that the European Space Agency is doing. The two of them together, as I said, this is an international planetary defense effort, are known as AIDA, the Impact and Deflection Assessment. And so we're going there this year to take a look. And Hera, the name for the European Space Agency spacecraft, is going there with a launch about 2 years from now. And it will rendezvous again, just as we did with Dimorphos a couple of years after that. And in this case, we're trying to get further detailed information of the crash scene, better measurements of the mass of Dimorphos, better not just measurements, but observations of the impact crater and the surrounding surface. And they're doing this with a combination of thermal and optical imaging and with LiDAR, which is, particularly useful for size and shape kind of stuff. There are CubeSats, and just to show you that the mission is not fully defined yet, they haven't completely decided, I don't think, how many CubeSats and how close to the surface, or whether some of them are going to land on the surface for their missions. So that's the European part of it. There's an absolutely great video of this, and I've provided Jeff with a copy of this slide and the next slide as a handout that he'll send to you folks, so you don't need to copy down this video address, but you may recognize this guy in the middle. He's not an 18th century English barrister. He's the Queen rock group guitarist who also happens to be a well-known astrophysicist. I'm trying to read his name, Brian May. So I imagine a lot of you have come to know him. Quite a well-known guy in NEO circles. At any rate, he narrates this video about Hera, and I recommend it if you want to take the time. And finally, I thought you guys would be interested in this, so this is part of the handout you're getting. The Minor Planet Center people put this together for folks such as us with the indication of what we'll be able to see with an 8-inch, or the fact that we can see it with an 8-inch. And, you know, astrophotography may be very useful if you do that sort of thing. And there's its trajectory as it comes through the window of impact somewhere toward the southern end of Eridanus, below Orion and Lepus. So that's where it's going to be. I intend to try to get a look at it about that time. Of course, I'm not saying we're going to see any impact, but we may be able to see the double asteroid system. So thank you very much. Appreciate your attention, and hopefully there are some questions.
Thank you, John. I don't know if you have I was trying to do the quick math in my head. What's the relative momentum or kinetic energy between the spacecraft and the smaller of the two asteroids? I mean, it's tiny, right?
Yeah, I believe yes, tiny is probably an appropriate word. I mean, we're talking about a smart car.
Yeah.
Hitting something, you know, the size of a bunch of 15-story buildings next to each other. Yeah, it's not gonna change things much.
Yeah.
But,
and I guess,
you know, it's a demonstration of a technique. I mean, if it doesn't, it'll be, nobody asked the scientists where they came up with the greater than 73-second change in the period. I wish I had now, and I may when if I get some conversation going with them. But no, they don't expect there to be, you wouldn't expect there to be much of a velocity change for such a mass. But if you have enough years before impact, and we find these things years and decades out, then a small velocity change is enough.
yeah, do you know, has anyone done the math to bring it back home in personal? Like, let's say we had a 5-year head start, how much of a deflection we would need to make, and how applicable this DART mission would be, or not applicable or analogous. You know, have they thought that far ahead, or is this really kind of the first step?
Well, I mean, we know it's the first step.
Yeah.
I am sure that many of these wizards have, you know, figured things out and have their own guesstimates and so on. I'm also relatively sure that in no way are they suggesting that a 633 kilogram space, you know, mass is going to be sufficient to do much to this. This is, as you just said, as I'm saying, this is the first test of a technique, just to show that we can do it. We can hit dead center. We can make a change that's sensible. And I'm sure then they have, probably by now, they've got tables built of how large the spacecraft's going to have to be for various sizes at various times at various velocity changes. I can't imagine that they haven't worked that out yet.
Yeah, because the math on that is relatively simple. I mean,
Yeah, it is, but the wild card among others is beta. And so the composition and the effect of cratering and ejecting material is not known except experimentally, I think. I mean, you can model it as they are and come up with wonderful numbers, but they want to get some empirical data. It's the usual way. Yeah, I'm really excited to hear what it is that they learn from this.
John, are there any plans for sending out spacecraft with, say this has a mass of 1,500 pounds or so? Are there any plan for doing any tests of sending out 1,500 pounds of high explosives?
The problem with explosives, especially for smaller asteroids, which are almost certainly, we believe, all rubble piles, is creating, you know, something that is potentially worse than what you started with. but you didn't ask that question. The answer is, I'm sure somebody is considering that. I'm afraid I can't tell you that I have any insights at all to what the community has considered and what the researchers have considered in the way of what test to have first. It could be that if this is successful and we learn enough from it, and perhaps learn that this is surprisingly not like a rubble pile, but more like an inelastic, solid object, that could be a good reason to decide either to have a certain level of explosives that we send up there or a different level, for example.
And second, in line with my thoughts on that was, are there any plans for landing a type of spacecraft that has thrustability to it that could add some momentum by the thrust of the motors of the craft itself?
Again, I'm not privy to what they're doing. Like you, I wonder, but I also immediately realized that carrying the mass of propellants that's necessary to actually have sufficient thrust to change much, as opposed to just smashing that mass into the object. There's, at some point, there are trade-offs here. Having said that, you think of things like, could an ion engine, if you put it up there enough decades in advance, do enough over a long period of time? I think the answer to that's no, but because for any mass that's actually a dangerous mass, I don't know. I would love to be back in the community, working in the midst of people that are dreaming these things up. These are good questions.
Yeah.
I'm afraid I'm not an expert on what they've looked at so far.
So, because we always have Bruce Willis and whoever else who was at the ready.
Well, Ben Affleck got into the act somewhere, I remember.
Yeah.
So I was wondering, with this spacecraft, unlike other ones, did they just add dead mass anywhere to it just to increase the weight and the momentum? Or did they just kind of make the spacecraft and say, well, that's the weight, I guess we're sticking with it?
Again, I don't know. And nobody asked the guy when we were talking to them. My guess is that that's the weight that all of the necessary stuff that's needed for communications and power and so on came up to.
Yeah, it's kind of a weird, double-edged sword or whatever you call it. Normally they try to make the stuff as absolutely light as possible, but that doesn't help you on that end.
Right. Again, you use your booster to launch ballast that's big enough to be a mass that there are all kinds of ideas, and I'm not going to pretend that I know what they've worked through and what parts of the decision space they've eliminated at this point, but I'm sure they've been thinking about these things for years. And it motivates me to try to get closer to the community and understand more about what they're actually considering in the mitigation techniques. Everybody got excited for a while about the tractor technique, but you have the challenge of sufficient time and getting sufficient mass to actually gravitationally get enough pull. And as you saw, that it takes a combination of not very large mass and many years to make it work.
Other questions or comments for John? Go ahead.
Yes, earlier you showed the graphic that showed that we have identified 4 objects in the 10,000 kilometer size. Are those objects actually potentially intersecting Earth's orbit, or?
No. Let's see. you can take those four, you can take the 800 and some in the next smaller category down. Let me just go back to that slide for a second. Give me a second here.
What did I do, Rob?
It's okay. You can click on that again.
I'm trying.
There we go.
Hold on a second, John, I screwed something up.
Click the view.
Oh, I'm not there?
I said,
This one?
Yeah.
There we go.
Am I there?
Yes.
Okay, so look here for a second, and just look at the bottom lines. So we got 4 plus 90% of 900, that's 810 roughly. So you got a little over 800. You've got about 8,000 of the 160 meter. That's, you know, like 9,000. And then you've got millions and millions of these smaller ones. And as we know from Chelyabinsk, even being 20 meter can be damaging. So we'd like to know about all of them. And we only know so far about what that works out to, if you do the math, is I believe several 100,000. So as I said before, the Minor Planet Center is tracking by number and by orbital elements, and we update it all the time with telescope checks on it. Over 500,000 of these, and as you can now see from this scan across this thing, the ratio of these of different sizes. And your question was, do we think the 4 are, we don't think, okay, blanket answer. We don't think any of the ones we now have estimates for their 10, 20, 30, 40, 50 year out positions as they cross Earth's orbit have any chance of hitting us. I mean, that's a very good thing so far. At some point, we're going to find one that is close, and then we're going to watch it and see what it does year after year. And has happened with one that I've forgotten the name of now here over the last 5 or 10 years. There was one identified, and now that we've tracked it more over a period of years, we've been able to establish that it will not cross our paths. We haven't found any that will cross the path, fortunately. I mean, if we do find one of those, another one that's 10 kilometers, that's even, you know, 50 years out, that it looks like it might cross our path, that is going to be an occasion for turning a very large budget to mitigation approaches. You know, for example, maybe sending nukes out there, you know, 10 years beforehand, if it's still on path, and then find out how many small pieces came out of blowing the whole thing up, and then find the ones that are still threatening us and use an appropriate mitigation technique on that. Who knows?
When new objects are found, how long does it take to get an accurate estimate of the orbit?
I don't think more than, well, you have to get obviously multiple observations. I don't know a good answer. They get identified, they get confirmed, they get put into the database with some orbital elements. And then I think there are probably a number of teams that try to work these things into a more accurate state by taking additional measurements and doing additional calculations, and with other telescopes.
Thanks.
There's a recent book called Chesapeake Invader that describes one that apparently in the, I guess, 2,000 meter range, 35 million years ago, and it fell into Chesapeake Bay. The book is interesting and written by a geologist, I guess, that explored it. He might have discovered it. I forget his name. He begins with a B.
Isn't the theory that it carved the bay?
What's that?
Isn't the theory that it carved the bay? I thought-
No, it landed in the bay, but the ocean was much higher, so it no doubt made a big splash.
Yeah.
And the evidence is the splash caused a tsunami, at least as far as Connecticut. And
Could you say the name of the book again, please? I didn't get it.
Chesapeake Invader. I just got it recently. I've only gotten a quarter of the way through it. Got it from Amazon.
Thanks.
35 million years ago.
Yeah.
roughly.
That's not a question, but yeah. Any other questions or comments for John? Cool. If not, we'll thank John one last time.
All right, folks. Let's see, I'm going to stop sharing. Here we are back.
Right on. And John, I did get your email and I will be forwarding that information on to our members. Just a couple of the notes and the slides that have some specific information. I'll be passing that along to everybody. A couple of reminders, as this is our June meeting. We take a summer break from our general meetings. We do not meet formally in July or August. Our next formal meeting will be the third Tuesday of September, which I have no idea what that date is yet, but it's easy to figure out. However, despite the fact that we will not hold formal meetings in July or August, we will continue our every Tuesday astronomy workshop. So some group will be here every single Tuesday for starting around 7 o'clock. And those activities range anything from working on projects to just hanging out and chatting to, whatever else might be going on. Observing if it's clear. Yeah, of course, we're getting into the summer dark late. The other thing is keep an eye on the groups.io for any types of activities that will be going on. We'll actually looking like we will be resuming some of our outreach events over the summer. Dave's been in touch with Woodside Farm Creamery. I know a lot of us were very fond of those outreach events and the ice cream that came along with them. In fact, we might be doing one very soon. So again, keep your eye on your email for all of the different summer activities, Friday Night Lights, Ap Sig, book club, astronomy workshop, or whatever else might be going on. So again, thanks to everybody and we'll see you soon. And refreshments. For those of us that are here in person, Diana, as always, has brought great refreshments. For those of you joining us via Zoom, I don't know, check your fridge. There's probably some refreshments in there. So take care, everybody, and we'll see you around.
Happy solstice.
Right here.
You can get it there, down there, Mr.